Okay, so this is 4.3. We're going to start with a warm-up first and then get into the notes on applying congruence and triangles. So far we've been working a little bit with triangles, specifically just learning lots of theorems about them, like the triangle sum theorem, and then all the extra ones from yesterday as well, and just how to apply them and finding different angle measures. Today we're going to get more to what we need eventually so that we can start proving things again. I know, because you thought maybe you were done with proofs. We are not, unfortunately. So this first part, though, just to start with something we have done already, to find the measure of an interior angle of a regular dodecagon. First of all, a couple of keyword things that we need to look out for. Regular means all of the sides and angles are the same. And then dodecagon means that there are 12 sides in this polygon. And so it's just something you have to memorize. Dodecagon is 12. And now we're ready to find, using that formula that we saw a couple of days ago. This is 180 n minus 2, but we know n is 12, so I'll plug that 12 in, and then we'll kind of figure out what should the sum of the angles be, because this equation right here is used to find the sum of the interior angles, all the angles inside of this dodecagon, but we want to find, again, one interior angle eventually. Okay, so first let's just substitute in 12 in for n. This would be 180 times 10 is 1800. So if the question just said, find me the sum of the interior angles, we'd be done. It'd be 1800 degrees. But we are being asked to find one angle. And since there are 12 sides, that means there's 12 angles. We need to take that number and divide it by 12. So that we should get our final answer for the measure of an interior angle is 1800 divided by 12 comes out to 150. So 150 degrees is what our answer would be there. Okay, so that one is just like the warm-up, just making sure we still know how to do that, moving forward into this idea of triangles and congruence. Now we know what a triangle looks like, and we know what congruence is when we've been working mainly with segments and angles. Now we're going to kind of use that idea and put it with triangles as well. So polygons are congruent if and only if all their corresponding parts, and in terms of the parts that they're referring to, it would be the sides and the angles of the triangle or of the polygon, those would have to be congruent. Now, I know it's kind of confusing seeing this word corresponding because in the last unit, that was different when we were talking about if parallel lines and corresponding angles congruent. That was talking about a position of like where the corresponding position is when you're looking at two lines that are parallel in a transversal. This is not referring to that same thing right now. It's just saying that if you have two polygons that you're looking at and you know they're congruent, then the angles that match up, the ones that are in the same spots, like the top angle with the top angle, the side left angle with the left, and so on. But the issue would be sometimes we can rotate things. We know we've done transformations, and so they might not look the same. If you look at some of these diagrams coming up, we might have changed the orientation of something, but it's still going to be congruent, because if you think back to the transformations, remember that there was isometry, or that meant that the angles and the side lengths didn't change as long as you didn't do a dilation. So we're going to look at some of our triangles here today, and they're going to be congruent. That means maybe a transformation occurred that is not a dilation, and it still is going to look maybe just oriented differently in a different spot and different place, but their size and shape should not be different because it is still congruent. Okay, so we are applying this idea of where it says polygons are congruent, but now we're just going to look specifically at triangles, because although this works for all polygons, I want to work mainly with triangles today. So if the conditional statement said, if triangles are congruent, then their corresponding parts are congruent, this is what it would look like in an example. We're showing here that these two triangles are congruent. W, V, U, and then that congruent symbol, G, H, I. So what you want to do here is actually match the angles and the side lengths and say which are the corresponding parts that it's saying are congruent. We need to know which ones go with which. And when you're looking at a diagram like this, I bet you're looking at it and thinking, how would we have any idea without some measures of angles or something else, right? So that's where this congruent statement, that's what this is called, a congruence statement will help us figure out which angles and which sides correspond. So what we're going to do is look at the first letter with the first letter, and they have to match. W would have to be with G. So we're putting one congruent ring around both of those. Then you look at the next letter, V, and you do the same thing. And I'll try to color code this too. So V would be 2 rings. And that has to be with H, because that's the second letter as well. So again, the order of the letters is telling us which angles are congruent. And then finally, U and I would be the last ones that are congruent. Now we would look at the side lengths the same way. The first 2 letters, V, W, and V, I'm going to put 1 tick mark there. Then G to H would have to get 1 tick mark as well. Do the same thing for the next 2 letters. V to U, it goes from V to U, it would be 2 tick marks. And then H to I is the next 2 letters, so it would be 2 tick marks here. And finally, that leaves us with UW for 3 tick marks and IG with 3 tick marks as well. Okay, so we've kind of marked up the diagram as best we can to show all the corresponding parts are congruent. Now we just have to write out our corresponding parts, like showing the statements. So let's look at the angles first. The diagram can help now because I can match the number of rings. Like W goes with G, I would write angle W is congruent to angle G. And then do the same thing for the other 2 angles. So V goes with H. And again, you can either look at the diagram because it's marked up now, or you can go back up to the congruent statement and say, okay, V was the second letter and H is the second letter. And that's how I know they correspond. And then we have the last one, U with I. Okay, and those are just the congruent statements for the angles. Now we have to do the side lengths. Remember, when you write side lengths are congruent, you need 2 letters, capital letters, like let's say I want to do the first 2 letters, W and V. I have to put the little bar on top of it for segment, and then draw the congruent symbol, and then grab the next 2 letters, or the first 2 letters of the next triangle, so G and H. And I could use the diagram also, where if you notice, I went from 1 congruent ring to 2. This one's going from 1 congruent ring to 2. And then same thing for the next few. So we have VU is congruent to HI. Again, don't forget the bars on top, because these are segments that you're describing with congruence. And then finally, the last one, if you write WU, because I went first letter, then last letter, then you would have to write same order on this last one. You'd have to do first letter is G, last letter is I. What if you switched any of the ones that I have? Like instead of writing WV here, you wrote VW. That is okay as long as you switch the second one as well. So I can't write VW with GH. I could do VW is congruent to HG, and that would be okay too. So it's going to be really kind of nitpicky details right now with making sure we write the correct order on these. Okay, so moving on to the converse of it though, this says if all the corresponding parts are congruent, then the triangles will be congruent. Pretty straightforward. This time, I'm not going to write out all the pieces because we can see them in the diagram that like angle J and T are congruent, angle R with K, S with T, S with I, and then you can see the tick marks also showing all the corresponding parts are congruent. So I can just go right to my final statement, which is that the triangles are congruent. Here's where we have to be really careful about the order we write our triangles in. For this first triangle, the way you write it, you can pick. You can pick the order you write the letters. Okay, so let's say I wanted to do JKI because I just want to count in order of the rings. Like I want to go first, 1, 2, 3. As soon as you figure out how to write the first one, the second one has to match it now. So the J has to correspond with T because that has 1 ring around it. So T has to go first. Then I did 2 next, so that would be R, and that would leave me then with S. So you have to write it either like this or in any other order. As long as you can change the first 3 letters, the last 3 have to match those first 3 then. So if I said IKJ, I would have to write SRT. And so on. Just making sure that they always match. And like there was an extra practice that you got yesterday that this stuff is all on. If you'd like some more practice with some of this, I would highly recommend doing that as well. So as far as like the notes, we are pretty much done, but I'm going to just try to go through a few other quick of these practice questions, because homework is going to be a lot of similar problems to this, just making sure we really get the gist of like, look at the order of the letters. I can't stress how important that is when you're trying these out. Okay, so for number 1, let's just try out, let's try the second one out. It says ZXY, look at the order of the letters, is congruent to ZXC. And so knowing the order, if you're being asked about angle Y, which is the last letter at the end here, you're just going to grab angle C for congruent. Okay, so that's all we're doing, just kind of filling in, looking at the order of that. And then for number 2, there's lots of possible answers, because it just depends how you write your first triangle. After that, you can pick. So I'll just do one of these. Let's try this one here. If I wrote, I'll just write here though that there are many answers possible. But if you're unsure about your answer, like is it going to work or not, just let me know. Or you can change the order of the letters on what you see here. So I'm going to write down the correct one possible correct answer, and you just have to see how yours is changed from it. So if I wanted to do just following the order of the rings again, SRI, then the second triangle over to the right here would have to be RST. It also does not matter which triangle you write first. Like I could have flipped this and that would still be correct, where it could have said RST is congruent to SRI, same thing. Okay, so you could try another one out as well if you'd like. And now there is a couple of proofs actually on the next page. I'm going to double check if your homework has any proofs, otherwise we may save those for the next day. Yeah, so homework tonight does not have any proofs, so we're going to actually hold off on proving any of those just yet. We're going to use that on probably on Monday to make sure we understand how to do those proofs, because right now, if we tried to do these proofs, there's actually a shortcut that will help us, that it would be probably in your best interest to kind of wait and see what the shortcut is, because it ends up being a much longer proof otherwise. This one's about 4 steps. And then number 5 ends up being like 8 steps. So I would not recommend doing it just yet. We'll talk more about it on Monday. But if you'd like to try out number 3, lots of answers possible with like how exactly your diagrams look. But I want to just do one of them real quick to notice that CD is a common side in both of those. So you could draw the diagram with a common side length, like C and D here. That means B could be over on this side, L could be over on this side. Doing your best to make sure they're congruent. I know it's hard to make it perfectly drawn, but something like that could work for a diagram for letter A. Okay, and then if you notice only one angle is the same and not a side length, then think about vertical angles when you draw something out for this one, because J has to be in both triangles, but they have to be congruent, so it's easy to kind of make them as vertical angles. But then the one that's tricky is this last one. J is in a different spot. Like here, they were both in the front. This one, J, one of them is at the very end, one's at the front, so they're not congruent to each other, because it would say that the H is actually congruent to this angle J on the right side. So you kind of have to draw the picture so that J is a common angle in both, but it is not congruent, so you don't want to make them vertical angles. You could do something like this, side by side, and put J like right here. That would tell us then that these two triangles, J is not the same angle, it's different for both, but that I and T, so if this is I up here and this is T, that could be how you could draw this instead. And then your H could go here and S could go here, right? So like a couple of, there's not a whole lot of answers on this one, not a lot of ways to do it, but you have to think through how you could possibly draw those. All right, we'll stop here, and then again, if you wanted to just at least do your homework first, if you want to come back and try out any of the practices that we skipped over, you could do that.